This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 6 of Vector Basics. And in part 5 we did vector addition and we did the graphical representation. Now we're going to use the component form. So let's say I have two vectors, and let's say I have vector E, and the component form is, let's say, 2, 1, and then I have another vector F, and let's say that is 1, 3. Okay, so two vectors. Let's see what this would look like if you're trying to graph these. Alright, so what it says, you could start off with vector E anywhere. I'm just going to do it on the graph because it might be easier to see the spaces here. So I'm going to go ahead and start at the origin, although that's not necessary, and I'm going to draw vector E. These are the components. It means if this is my starting point, I'm going to go over 2 spaces and up 1, and that is vector E right there. That's one place you could put it. Now you could put that anywhere on the graph, right? And then we're going to, from the endpoint here, graph vector F, which is, let's see, so I got to start at this point. I got to go over 1 and up 3 spaces. So I end up right here. Okay. And so my final answer would be this vector right there. Okay? So if I want to do E plus F in blue, what vector is that? So I have to look. Here's the starting point and the end point. How would I get there? I would go over 3 and up 4. Okay? So there's a picture of me doing it. Now you might have seen that there's kind of an easier way to do that. Let's say I had written E as 2, 1 and F is 1, 3. You might have noticed that in our resultant vector over here, it's really the sum of the two first components, 2 plus 1 and 1 plus 3. And it should make sense because when you begin, you really go this many spaces in the x direction, 2 spaces, and then you end up going 1 more space in the x direction. So you end up with 3 spaces in the x direction. Same thing for the y. You start off going up 1 in the y direction, you eventually go up 3 more spaces for this other vector, so you do end up going 1 plus 3 or 4 spaces up. And in fact, that's all there is to adding vectors. You add the first components for your new first component, and you add the second components. You could try these with negative numbers. Let's do one with negative numbers. So here's our problem. This is one vector, negative 3, 1, plus a second vector that has these components, 5, negative 4. Now I could have called this vector v and this vector w and said what's v plus w, but it's okay just to simply write the vectors in this form. So using what we think the answer would be, I would add the first components of each, negative 3 plus 5, and the second components of each, 1 plus negative 4, and that should be our resultant vector. That's like saying the sum of two vectors. So that will give you 2, negative 3. Let's see if that makes sense graphically. So if I start with the first vector, negative 3, 1, so I'm going over negative 3 and up 1, I have this vector right here. Now I don't have to start at the origin, it's just easier because then at the end, wherever the ordered pair ends up, that's really going to be the same numbers as our vector is going to have. its components. Okay, so I've got negative 3, 1. That's the first vector. To that, I'm going to add 5, negative 4. So from here, I got to go over 5 and down 4. It's going to be right here. So from the endpoint of the first vector, I draw the second vector. And then this will be my, okay, I know it's like a sketchy vector here, but this is the final answer, right? And what vector is that? Well, since I started at the origin, it's whatever ordered pair that is, right? Over 2 and down 3. It's easy to read this way. So that's 2, negative 3, which is exactly what I have right here. What if you would have started the first vector somewhere else? You really don't have to start at the origin. You could say, okay, I'm going to start, somewhere else. How about if I start like right here? Okay, start right here. And let's do negative 3, 1. So we're going to go over 3 and up 1. There's my, it's hard to draw, just negative 1, up 1. Okay, there we go. There's the first vector. And then from that point, I'm going to go 5, negative 4. So I'm going to go over 5 spaces, which is right here, and down 4 spaces. I think it's going to be right here. Okay. And I draw that. That's the second vector. So my answer would be right here. Let's see. Let's do it in red again. And that again is over 2 and 1, 2, down 3. It's the same vector. It's just easier because if I start at the origin, because I just look at that ordered pair, 2, negative 3, it's gonna have a correspondence with the way I write my vector in component form right here. So here's our summary of vector addition. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.